Hello, my name is Jeff, and I'm calling this Cartesian Intelligence, the name of these talks. And subject of today is the nature of intelligence. So, can we use mathematics to define intelligence in life? Can we understand the mechanics of intelligence, how it works? Can we understand? Can the understanding of intelligence be used? How does artificial intelligence relate to just intelligence? So years ago, decades ago, when the first round of things talking about artificial intelligence, I don't know when the term was coined, but as soon as I heard that, I didn't start thinking about computer systems. I started thinking about, well, I don't know what intelligence is. It's just like artificial vanilla. I should compare that to regular vanilla, right? Artificial intelligence, well, I don't know what natural intelligence is. And that started me thinking about what is intelligence. And I've been thinking about for quite a while. And what is this thing? So I'm going to try to use mathematics to describe it because, or the concepts in mathematics, I should say, not mathematics itself. Use that to explain this because mathematics is a really nice way of explaining a thought process. Now, it doesn't explain all thought processes, it explains a very limited range of thought processes, but it's really one of the few things that we have that describes a thought process. And so it seems like a good place to start. So, subject of this talk, we'll attempt to define intelligence. We'll use the definition of intelligence to understand the uses and limits of intelligence. We'll show that evolution and the scientific method are intelligent systems. By my definition of intelligence, which is sort of different than others out there. We'll show an example of an intelligent system and might even answer what's known as the Fermi paradox, us searching for intelligent life. How can we do that? How would we know? There's many directions that this can take with intelligence, and that's just a few of the examples here. So I'm starting out here. So as I said, something like artificial intelligence, that's really sort of used to sell computers or software systems. If you look up intelligence, there's books on this, many websites on intelligence, but they're really getting it from the human perspective. I grabbed this off the internet. A very general mental capacity that, among other things, involve the ability to reason, plan, solve problems, think abstractly, um, complex ideas. It's not merely book learning, things like that. As I said, to understand intelligence, I felt the best way is instead of looking at the most intelligent, highly intelligent people, try to look at the simplest thing possible that I could call intelligent. And by doing that, I could try to get a handle on what intelligence is. So instead of so word intelligence is used many different ways and in many different fields. And maybe I should even use the word intelligence. Maybe I'm talking about what I'm looking at is something so different that maybe the word intelligent isn't the right thing to use, but I'm using it anyway. Maybe a mistake. So, what is intelligence? Well, um, humans have a spleen. Other animals have a spleen. Humans have eyes. Other animals have eyes. They have a kneecap. the evolutionary the kneecap didn't come out of nowhere. It must have been around before us, just like the eyes are and the spleen. There's an evolutionary history to that. We should think that about everything with humans, that things just didn't appear with humans out of nowhere, that we're not unique. We are unique in that we have cars and computers and airplanes and things like that, and dolphins and squirrels don't have those. But unless shown otherwise, I'm going to assume that what we have as humans has been around evolutionary way before us. So start out with that assumption. So unless someone tells me, or unless it can be proven this is unique to humans, I'm going to assume that it's not. And that's just true most of the time. So assume humans are not unique among life on Earth. Intelligence, assume that's a useful thing. Okay. If it's useful and it's here before humans, intelligence should be common. What is the minimum for intelligence? And then what is this thing, intelligence? Is it a mathematical equation? Can I write that out? Is it a chemical or something like that? What category of things is intelligence? Let's start out with mathematics that I talked about before. Mathematics, is this the ideal thing? Is this something, some people felt that mathematics was like discovered, that mathematics existed when the universe started, perhaps, and that humans simply discovered this mathematical system that's already been there. Um, and, and the other view is that mathematics was a human construct. Um, like language, now we're not the first to have language, but English, German, whatever, Portuguese, those were languages that are these, it's a human creation with that, those branches of language. Is mathematics something that you had choice in that wasn't discovered? Anyway, they felt that mathematics was this thing that was discovered, and they felt that they could start with fundamental principles and build through all of mathematics. And this was wonderful if they could do this. Um, you'd have maybe the possibility of like not having to do another scientific experiment because you have a mathematical system that describes all physics. That's already there, and we're discovering it, and we could use that instead of doing experiments. And so they felt this way, and they worked through slowly. I guess the book takes about until page 50 to get that 1 plus 1 is equal to 2. Well, there's a counter to this argument that it was discovered. We get to Gödel, who felt that the opposite, that it was invented, that it has to be invented. So I start out here. Pigs can fly. There's something wrong with that sentence. What's wrong with that sentence? Well, if you know about pigs and you know about flying, you know that that cannot be true. That is a false statement. The second statement is what's known as the liar's paradox. This statement is false. There's something wrong with that statement. If the statement is true, then that's false because it's false. But if that's false, and that's true, it self-contradicts itself. The thing wrong with that sentence is within that sentence, and we get to isolate the thing that that Gödel was interested in. This this logic, that we can have something that logic itself fails with. And so this, as I said, this liar's paradox. And he felt that if he could get an equation that did this, that was a self-contradictory equation, that he could show that mathematics was invented or has to be invented. So really, in a sense, the same tools that are required to prove a system would also work to disprove that system. So if a system's proof existed within that system, then and that worked, then the disproof would also exist within that same system. Therefore, the proof and the disproof are both there. Therefore, the proof is outside of the system. And he worked with invented some terminology, some ways of thinking, where he went and uh, said every mathematical function could be described by a number, and you have prime numbers, and you have numbers that are not prime that are made up of other functions, and that you could even have an infinite number of functions out there. Anyway, he went and used this mathematical system to essentially show that that the solution cannot be within the system. And one of the things about this is that if his system was correct, then it would disprove itself. By showing that he cannot prove this, he went and essentially proved it. By showing that it's impossible to prove it, he proved this, and this is what's known as an incompleteness theorem. It's not the first incompleteness theorem. I guess there's others out there before this, but it's the most famous. So the proof of a system cannot be part of that system. Now, because the above statement refers to all proofs in all systems, a proof of that statement would contradict itself, since that is a system. So as soon as you prove this to be correct, it would be proven to be incorrect. And as I said, self-contradict itself. And I have a little picture of, this is not a pipe. A picture of a pipe is not a pipe. So this is metamath. Gödel's incompleteness theorem is metamath. It uses the structure of mathematics, but it's outside of mathematics. And it shows that mathematics has some choices, that is, in a sense, at least partly constructed by humans. People often think this is a limit on mathematical systems, but to me, this is good news. What this means is that you can have more than one mathematical system out there, that we can choose mathematical systems. And to me, I think that expands things instead of makes them more narrow, that there are choices at the beginning. So what are other metamath systems? A random number is metamath, because you have a function, you put in the same number, you should get the same number out again. It's repeatable. A random number function is metamath, because you put in a seed number, you get out a totally different number, not the same number every time. You cannot make a function with that, so it's metamath. Scientific method, mathematics and things that are generated from that are metamath. Why is that? Well, it gets back to being more than one mathematical system out there, that we have to use experiments. We might have a mathematical system, not all science has this, but you might have a mathematical system that explains like what's happening with physics. But is that correct? Well, you have to have experiments to show that that's correct, and that's outside of that system. And if you don't have experiments, you're not science anymore. You're something else. Evolution is, I'm calling it metamath. It's a meta system, because it relies on natural selection. So we have genes, and they describe what's happening here. But are these genes working or not? We need something outside of that, survival of the fittest, to